All right, so like I was saying, hopefully much of the material that I'm going to look at today is review from a previous class of yours at some point in time. But again, to make sure that we're all on the same page, I have to do this. Plus, it's probably been at least 2 years. So we need to get back in the game a little bit. First of all, one more term to define, and that is the word ion. I'm sure you were introduced to the concept of ions at some point in time. Does anyone recall what an ion might be? Yes, Rena.
A charged particle.
Why is it charged?
Because it either has more protons than electrons or more electrons. Oh, wait, no. More electrons than protons or less electrons.
That's a good way to say it, because I know sometimes students get in, it has different numbers of protons and electrons. Okay, that's true. However, if you're talking atoms of the same element, the protons stay the same. So let's focus on the electrons. Okay? But she is right. Whoa, whoa, whoa. So an atom that is an atom or group of atoms that has acquired a charge due to the loss of electrons or gain of electrons. And I split that up on purpose. I'm going to start the process. It's going to happen. It's going to take like 2 or 3 different times this year to fully complete the big picture. But we're going to look at this process of oxidation and reduction, which is directly related to the losing and or gaining of electrons. By the way, please do not spell the word lose like this. That really annoys me and all the rest of the intelligent people in the world.
I lose electrons.
I
lose it.
all right, anyway. I lost as in L-O-S-S-E-D. I've seen that.
I lose them.
You guys really need to have my perspective someday. Anyway, loss of electrons. There's an actual term that goes along with this. That term is called oxidation. That process of losing electrons or having undergone the loss of electrons is called oxidation. The species, I'm going to say species because it could already have a charge, or it could be an atom or a group of atoms. So I just put chemical species. Okay? Becomes more positive. Why does it become more positive? Well, Rena kind of already explained that. If you're losing electrons, you now have more positive charge than negative charge. Now, I also emphasized more positive because if you go from, say, +2 to +3, you've become more positive. Or if you go from -7 to -2, you've become more positive by losing electrons. You may not end up being positive, but you become more positive. And then there is the gain of electrons, which is called, this will really kind of boggle a couple of you, Mackenzie, reduction. So gaining electrons is referred to as reduction. And in this case, the species becomes, well, you can say it either way, really. Doesn't matter. More negative, or, as I heard someone say, less positive.
Hey, I have a way of remembering that.
Yeah, there's like 18 different ways. You pick whatever you want. Seriously, there's a ton of ways to remember that. I don't teach any of the ways because I would rather know the thing than know the thing to know the thing. All right. Anyway, this is my brief introduction to the process of oxidation and reduction. We're not going to do much more with it yet, but we will do a lot more with it later. I will say this, though, you can't have one without the other. The electrons have to go somewhere, or the electrons have to have left somewhere. Does that make any sense? Okay, so you can't have one or the other. They actually work in conjunction with each other. Okay. Yes?
So then, are oxidation and reduction brought on by chemical changes?
Yeah, well, yes. Well, no, they're an indicator of a chemical change. There is a chemical, when a redox process occurs, oh, by the way, it's called redox when you put them all together. Apparently, ox-re doesn't sound right. Oxidation, reduction, ox-re. I called it redox. Okay, so anyway, redox processes, that is a chemical change. Yes?
So, like, if oxidation happens, but, like, the charge still stays negative, like, is it still, like, you still call it oxidation?
Yeah.
But it has a negative.
How did it become less negative?
It lost the electron.
And which is called oxidation.
Okay, so it doesn't matter, like,
No.
charges.
Nope. In fact, we're right in the middle of doing all that stuff in AP right now. Later in the course, in 2 more opportunities, like I said, when we get to basically what my AP kids are doing right now are what we're going to do later this year. So I kind of introduce it with you guys. That way I can fly through it really quickly with those guys and move on to bigger and better things. Anyway, moving on. Going back to the nuclear symbols, what we're going to start doing is looking at the number of particles in a nucleus, or sorry about that, in an atom. Just for fun, let's revisit a nuclear symbol. Do you guys, I'll just make a new one. Pick an element. Carmen? Abuga? Gold. Oh, look at her go. Give me a second. 79 and 196. There we go. And let's go with 198. Okay. So here's just a random isotope of gold, and I'm going to add one more little piece to it. Now we know what the top number in the left-hand corner represents. That is the, you know what, oh, I did something weird. That is the mass number, which represents the number of protons and neutrons. This is the atomic number, which represents the number of protons, and this is its charge, okay? So this, we will start throwing this in there. That's the convention for writing charges, is writing the number first, then the sign. I wasn't at the meeting, so I don't know. All right, next. So what does all that mean? Well, don't write anything down until I say write this down, because I sometimes forget what I'm writing and or, well, just for fun. How many electrons would this species have?
80? No. Oh, wait, no, 76.
76. It has a 3 positive charge, meaning that it has not additional, but it has 3 more positive charges than it has negative charges. Therefore, what process did it undergo? Oxidation because it lost electrons. You guys with me? All right. Next. Again, don't write this down yet until I'm done. Name. Symbol. Atomic number. Mass number. Number of protons. Number of neutrons. Boom. Okay, go. Yeah, write that down across your page. We're going to make a little chart. You guys have probably done something very similar to this.
How large will the chart be?
Well, you know what? If you should have at least a quarter of your page left. If not, because we'll probably do enough examples to possibly fill up a quarter of the page, depending on how much you write, how big you write. Mackenzie needs about this much space to get 5 examples in. And I'm going to take a stab in the dark here. Oh, no, you're fairly normal. Don't let that go to your head. Oh yeah, I don't see very many big writers in here. Sometimes I get big writers that are like. Okay, now, does anybody recognize where this might be going? It's okay if you don't. You possibly will. You kind of do. All right. So I'm going to start off with a really easy one. I need an element. Pick an element. No, don't. Come on. Oh, bismuth. I like bismuth. Here we go.
Gallium.
Second. Yeah, I got it. That's not a name.
Oh yeah, I was like, wait.
Now, I would suggest at this point in time, possibly, you don't have to do this, but possibly, because you can do it without, different colors might be helpful. Because what's going to happen is, I'm going to give you various combinations of this information. You have to figure out the rest of the information from that. And so now it might be hard for you to figure out what was the question and what were the answers. The other way to do that is if you just underline the things that. Okay. Oh, dang it. I forgot to do something second period. All right. Anyway. Here we go. So this is about as easy as you can make one of these things, but it's a good place to start. Okay, so we know what's going on. First of all, what is the name of this isotope? Almost right. Bismuth 210. Because there's more, it could be more than one isotope of bismuth, so we have to know which one we're referring to. Okay? What is the atomic number, everyone together now?
83.
What is the mass number? Whoa. What is the number of protons?
83.
Neutrons.
79.
That would be 127.
And electrons. 79.
Where did you go 127?
By taking the number of protons and neutrons and subtracting it from the number from that the number of protons. Okay? Again, that's about as easy as you can make one of these. But you get how it works out. You see where we're going with that. Okay? So next question. I'll pick the element.
Have you never seen this? Anybody notice how we used to do tables like this? Yeah, we used to do this.
Yeah, this is what I'm saying. You probably did something like this. Similar. I don't know if you did ions or not. You may have.
Oh,
I'm actually going to let you guys see what you can do with it.
I like that you put in
I need my
so many lines. It's like
He
4.
did say to have it out for the rest of the year. Oh, yeah. Rena, I don't want to hear you. Kristen bullies me.
The assumption is you're just going to have that sitting in front of you. I'm going to go help this young lady on her quiz. Number 4 is false. Number 4 is false. No? Oh, okay. I just scared a person. I do that a lot. I told her number 4 was false.
I'm good. How are you?
So have we identified the element? Excellent.
Chromium 54.
And therefore its symbol is?
It's ER.
Yeah.
54 on top.
So 54 over 24.
And then 6 plus.
Ooh, look at you go.
Nice.
Atomic number? 24. Neutrons? 30. It doesn't get much harder than that.
Well, I mean,
Are you sure?
Oh, wait a minute. I just got one. No, one more. I'm sorry, what? No. Somebody had a question. Oh, was that your question? Oh, so what's your question? How do you figure it out? How do I figure what out? Which piece are you asking? Which element? So, number of protons, which is indicated by the, remember the atomic number is the number of protons. So, 24, go to the periodic table, chromium. Silly.
No, do hydrogen.
I don't know yet because he wants to do this, so I don't know. I'm just saying elevator. No,
Towards your back.
but he wants to send fun with us.
I cannot make it much harder than that.
Can we get this so that it makes
I'm probably going to make fun of that girl again.
What if you give us nothing? The hardest it could be. That actually would be the hardest it could be. You can't say that was the hardest.
it would be impossible.
Yeah, right.
No, unless we guess all of these elements.
I guess that would make it pretty hard. And then all their individual isotopes and then all their possible charges that they can form. So you're going to make up like 500 of them.
Exactly. That's the hardest it can be. Right?
Ready, set, go.
I think I may have gotten it.
Excellent.
Yeah, me too. I tried my best. I feel like I did this one.
You get it, you get it.
I don't get it. Carmen's like, no. Rena? Maybe I
Oh, no, I didn't see the
I'm sorry, what?
Yes, Kirsten, you're practicing joining the class. Oh, I forgot you were.
Out to the world.
Hey.
Mackenzie, how you doing?
I'm getting there.
You got it?
I'm on the same answer. I'm still working on it.
Okay, but I mean, you feel confident in where you're headed? No.
Slightly, but I don't know. I got to the point where I didn't know which way to go.
Robert, how you doing?
Me?
Yeah.
Pretty great, actually.
Okay.
That was distracting. I'm doing okay.
Jackson, how you doing?
Really good.
Oh, excellent, excellent, excellent. Miss Manelli, how are you doing?
She's so focused.
Have we identified the element?
Yes.
What is it?
Phosphorus.
Excellent.
Phosphorus 31.
You want a phosphorus? I bet you do.
What over what?
31 over 15.
Yeah, you added.
31 over what? Excellent. Atomic number.
15.
Mass number. Proton. 15. All right. You can't get much harder than that. This isn't supposed to be hard, okay? I made it about as hard as I could possibly make those last two. It's not hard. Just don't screw it up.
Can we do more of these?
Yes, you can, when we have an assignment and a quiz and a test.
When?
Soon. Next Thursday's the test.
Next Thursday?
Yeah. It is.
Is that the test where we have to know all the elements?
No. Okay, next. That is as far as I'm going to go on this.